So that changes the problem, because instead of playing the prisoner's dilemma just once, you're now playing it many, many times. And if I defect now, then my opponent will know that I defected, and they can use that against me in the future. So, what is the best strategy in this repeated game? That is what Robert Axelrod, a political scientist, wanted to find out. So in 1980, he decided to hold a computer tournament.
He invited some of the world's leading game theorists from many different subjects to submit computer programs that would play each other.
Axelrod called these programs strategies. Each strategy would face off against every other strategy and against a copy of itself. And each matchup would go for 200 rounds. That's important, and we'll come back to it. Now, Axelrod used points instead of coins, but the payoffs were the same. The goal of the tournament was to win as many points as possible, and in the end, the whole tournament was repeated 5 times over to ensure the success was robust and not just a fluke. In total, Axelrod received 14 strategies, and he added a 15th called random, which just randomly cooperates or defects 50% of the time.
Hey, how about we code this system and strategies the Veritasium is talking about? Yeah, let's go.
Let me brief you about the Veritasium's video. In his video, he talked about a game theory called Prisoner's Dilemma and an experiment in which one researcher asked his contestants about to submit the strategies. Strategies are basically computer programs, and these strategies will play against each other and get points according to the moves they made. Strategy can make a move which can be either cooperation or defect, and based on his move and opponent's move, they both get points. We are going to code this whole system and strategies he talked about. And at the last, we will make these strategies play against each other. And let's see the result, what we get. Yes, it will be a lot of fun and equally educative as well. So stay tuned and let's start. I'm going to use Golang for this. And yes, Golang, I love Golang. Golang is a pretty cool language. So we are going to use it. Let's see how we can break down this whole thing into simple parts. Let's make our project directory first. We'll call it Prisoner's Dilemma. Code Prisoner's Dilemma. We'll open our VS Code here and okay. So first what we'll do. First, we will do initial setup, like where we will write our strategies, how we will write our strategies. Basically, we will prepare our models, require models, and basically we will set up our ground. Okay, where we will write our strategies, how this will play against each other, and then we'll start writing strategies. Now, strategies can be of 2 types, as Veritasium told in his video. Strategy can be either nice one or nasty one. Okay, so what I am going to do, I am going to write 5 nasty strategies and 5 nice strategies. Then here is a fun part. Okay, then I will leave up to you. I will open source this thing. You can write your strategies same way scientists did for their contestants, like to submit their strategy. You can write your strategies, and we will set up some flow. At some period, we will run this strategy against each other, and I'm telling you, it will be a lot of fun. Okay, we'll write 10 strategies, and then we will make those strategies play against each other. Okay. Basically, we will run this and we'll write some scripts or program to extract the result or analyze this. We'll prepare some charts or plot some graphs, and we'll do a lot of. Let's discard this. Let's start. So let's start by defining our structure, project structure. We'll have models. we'll have main.go. We need to initialize our module. We'll call it Prisoner's Dilemma. And it will be a package main, function main. We'll have models called player who is going to play. We will going to have a strategy type package models. Actually, this should be an interface because all the strategies are going to implement this interface. Okay, it will be an interface. It will have a function called next move, which will take previous move and return a next move, previous moves of opponent, and return the next move. Okay. We need a move model as well. Move can be no, it won't be a struct. It will be an enum, not rock. Move type. It can be of cooperate or it can be defect. This will take previous moves and return a next move. So we'll have strategies folder. Here we can define our strategies, which we will write, which will implement this interface methods. Okay. First, we can start with random.go. This is just we are testing out. We are not writing actual strategy. Type strategies, not type package. Strategies. Random strategy. This will implement this interface. Let's return this for now. So basically this random strategy structure, this is a strategy which implements this. Okay. And okay, player will have strategy. Player also needs previous moves. And in our main program, we can make players. And player will need strategy. Strategy, we will make a constructor, new random strategy. It will return a new random strategy. Okay. random strat, new random strategy, and we can give this random strategy. This player uses this strategy to play. Then we will make a game structure. And game will be between two players, so P1 player and P2 player. It will also need how many rounds the game lasts. Basically, in Veritasium video, he talks about 200 rounds something. We'll see. Function new game between two players and rounds. This is intelligent. GitHub Copilot is intelligent. We created this game. We can do new game between P1 and we also need second player. Let's make him use this strategy for now. We'll make another strategies later on. 2 players and 200. Okay. Game also needs to have a function called, you can say, start. So we are making this 2 players to play a game and it starts. Now what do we do in start? Start basically, oh yes, this looks correct. It lasts for rounds given to this, and player 1 makes a move, player 2 makes a move, then we append to player 1 moves and player 2 moves. Okay, this looks correct. We can also do points system. Or yes, between score between 2 moves, and if both are cooperating, both gets 3.33. If both one cooperates and one defects, who is defecting gets 5 points. This gets 5 points. This means both are defecting and both gets 1 point each. For that, player also need to have points, which will be an int, and after they make the move, player 1 points, player 2 points, we get the score and we increment those. Okay, cool. And now we can try running this. It doesn't print anything. We'll print each round to just debug what moves they are making. Of course, they will make cooperate move because we coded this to return cooperate always. Instead, what we can do? We can do random number. Yes, either 0 or 1. And if R is 0, we basically return this. And if R is 1, we return defect. Okay, this randomly selects anything. What we do here, we do fmt print P1's move and P2 move, and we basically sleep for 1 second. Go run. 0 0 1 1 0 1. Let's do a thing. This 0 1 is not really intuitive, so yes. Cooperate or defect. Game. Now it should print C or D. Okay. D. Both defects, both cooperates, one cooperate, one defect. Run this for 5 rounds only. This game for 5 rounds only. And at the end, we print the points. Okay. Cooperate, defect, cooperate, defect, defect, cooperate. Okay. Player 1 gets 10 points because it cooperates against defect 3 times. So it will be 5 points for this defect, and 0 for player 2, and 0 for player 1, and this 2 5 means 10. Okay, this looks correct. Our basic setup is done. Now we can do these things like strategy 2 dot go, like any strategy. Strat 2 strat package strategies, and this implements a strategy. So it will need a function called next move. Again, it randomly selects anything between this. Now we can do it here. Strat 2. We are missing constructor here, so let's make this. Okay. New strat 2. Now player 2 uses strategy 2, and so this player uses random strategy, this player uses strategy 2, and both are playing 5 rounds. This is our basic structure. Okay. We are done with basic structure, guys. Now I will write these 5 nice strategies and 5 nasty strategies as we discussed before. I will shoot this tomorrow, so my t-shirt will be changed in 3, 2, 1.